Today's linear use of oil, where oil is circulated until it degrades, then discarded and replaced with new oil, is extremely unsustainable and inefficient. This is, however, the norm, mainly because to date, viable methods for reusing oil have not been available. SKF can now present a solution to this problem: double separation technology from SKF RecondOil. Double separation technology can not only contribute towards a more sustainable industry, but towards reduced oil costs and higher performance as well. Today, an oil's lifetime is limited due to degradation. This is caused mainly by contamination. The oil gets contaminated by small particles, dirt, water, air, and so on, some of which can damage equipment and products. Depletion of additives. The additives that give the oil specific properties and functionality are consumed by the application. Oxidation. Oxidation causes the oil to degrade and lose its properties, and when the oil is degraded to such an extent that the function is lost, it must be replaced with new. If we zoom in on the contaminant particles in the oil, we see that they come in various sizes, anywhere from centimetre size all the way down to micron and nano size. Let's focus on these submicron particles. Getting rid of nano-sized particles is the big challenge. Instead, they pass through filters and accumulate over time. Eventually, the oil contains billions of these nanoparticles. Their combined surface area is vast and acts as a catalyst for oxidation. And while oxidation can also be caused by ingress of air and increased temperatures, more than anything it is driven by the accumulation of nanoparticles. Oxidation is a chain reaction, which once it has begun, proceeds at an exponential rate, causing the oil to degrade. This means that even if all the micron particles are filtered out with the best filters on the market today, the oil will eventually degrade due to oxidation. Oil degradation is affecting application performance. For the three main groups of oils, metalworking, hydraulic and lubricating oils, the performance effects can be severe. The main function for metalworking fluids is cooling. In these fluids, oil degradation results in coatings on surfaces. These can prevent proper heat transfer, which leads to a decreased cooling effect. In hydraulic systems, oil is used to transfer power, but oxidation and polymerization give rise to varnish, which can lead to decreased power transfer. For lubricating oils, the main function is to reduce friction. Oxidation can cause the viscosity to change, which affects the lubrication properties. In the end, when the oil has degraded to a point where it has lost its specific properties, machinery and output are at risk, and the oil is therefore discarded. Unfortunately, a lot of it is dumped or burnt as fuel oils, causing severe environmental impact. Only a small part of it is recycled, often into lower-grade base oil or asphalt. But imagine if there was a way to get rid of the small particles that cause oil degradation, a way to not only remove contaminants, but also to prevent the oxidation that causes the oil to age. With double separation technology from SKF RecondOil, there is. SKF RecondOil's double separation technology, or DST for short, has its roots in biochemistry. It is an advanced process involving chemistry, process know-how, and mechanical separation. Our technology is capable of removing the submicron particles to obtain an oil cleaner than ever before. By removing the nanoparticles, and all other particles as well for that matter, DST maintains the oil's original properties and prevents it from aging. Therefore, the oil never reaches a point where it needs to be discarded. Instead, the oil has a virtually indefinite service life and enables a fully circular use. And interestingly enough, when it comes to the performance of the main groups of oils mentioned earlier, there are other benefits as well. Off-the-shelf virgin oils are never completely free from contaminants, but with the DST process, we can purify the oil to higher levels of cleanliness than completely new oil. As a result, in some processes, the DST-treated ultra-clean oil provides higher performance than new off-the-shelf virgin oil. In other words, the output of a production process could be higher and more stable. So this is how it works. The DST process takes place in a system that is either integrated into the existing oil circulation system in the application or in a standalone unit. The systems are scalable, and their size depends on the volume of oil treated, level of contamination, and required throughput. We can adapt the technology to the system at hand. Let's now zoom in to understand how the process works at a microscopic level. The regeneration process takes place in settling tanks. To begin the oil regeneration, a classified chemical composition, which we call a separation booster, is introduced into the oil. The booster's chemical composition and surface polarity attracts contaminant particles of all sizes. They cling to the booster droplets and then clog together in bigger clusters. Eventually, the contaminant particles are absorbed by the booster, and as the mixture of dirt and booster has a higher density than the surrounding oil, gravitational force causes it to settle. Once the settling is complete, the residual sludge is removed and disposed of according to local waste regulations. As it is a concentrate of all the contamination, compared to conventional disposal of the full oil volume, the quantity of waste is minimal. The remaining DST-treated oil is then passed through a specialized mechanical filtering step to ensure no leftover booster oil remains in the oil. After this, the oil is ultra-clean and ready for reuse. It's a delicate process. The oil needs to be at a specific temperature, the correct amount of booster to be mixed into the oil at just the right speed, and allowed to settle for the right amount of time. To calibrate and customize all process parameters is part of the core know-how of our technology. While the DST process itself does not remove necessary additives from the oil, some of them are consumed by the application. To keep the oil's performance properties intact, the additives are topped up when required. An important part of SKF RecondOil's service is therefore monitoring, sampling, analysis and testing to keep close track of the oil condition. The result: an oil that is cleaner than new, that can be used again and again. A truly circular use of oil. Across industry, we need to increase sustainability and conserve resources to a much greater extent. SKF RecondOil is one of SKF's contributions to taking on this challenge. With the DST technology and our new innovative business models, we offer the industry a way to transition from an unsustainable linear use into a circular economy of oil.